All right, everyone. So here we're going to start with our Unit 9.1 notes. We're moving into Unit 9. So where we came from with Unit 8, looking at proportions and the confidence intervals we can create from those, trying to capture the true proportion of your context. Now we're going to be moving into significance tests again for proportions. So we're still in that world of proportions, but now we're looking at significance tests and if we have evidence of claims happening or not. We're going to start the first two lessons with this whole scenario of, is Mr. Gomez a good free throw shooter? So I've already filled some of this in just so it shortens the video and I don't have to write as much. I'm still going to explain everything and fill in what you have. If you want to, you can pause the video. I know you can see the blue ink, but anywhere that's blue ink, as a reminder, is what you would have said in class. So maybe take a minute and challenge yourself. Can you fill these things in on your own? Anyways, Mr. Gomez claims he's an 80% free throw shooter, and I don't believe that. I believe he's a not that good. So to prove his skills, he's going to shoot 50 free throws. And when he did this in front of me, he made 32 shots, not an 80%. Now, when we talk about identifying population parameter sample statistic, don't forget that some of these things we don't know. We don't know all possible free throws by Mr. Gomez, but that's our population. We'll never know how many free throws there are because they could keep going forever. We do know the sample, though, is 50 free throws from Mr. Gomez. It's that 50 shots he took. Likewise, the parameter goes with our population. We're not going to know the true proportion of free throws made. We're going to generalize using our statistical skills, but that's why it's P equals the true proportion of free throws made. We don't know that value. Like in a similar idea, though, we do know the statistic. It's P hat equals 32 over 50, which is 0.64. We do know that value. The P hat is our sample. That's something we know. Now, going on to like this second part of, there's two possible explanations for why Gomez made only 32 out of 50 shots. The first claim, and it's Mr. Gomez's claim, is that he really is an 80% free throw shooter. Maybe something happened and he just didn't do very well. My claim is the second claim, that Mr. Gomez is a less than 80% free throw shooter. Again, that comes from the top part. I don't believe him. I don't believe he's that good. Now, what we're going to do next, in class, you would have done a simulation here where we had a spinner with 10 sections that are the same size, same everything. And you're going to do a spinner and take 50 samples, and 8 of those spots have make, 2 have miss, to simulate an 80% free throw shooter. What I'm going to do here is use one of these staplets that we have. And we're going to do this activity here. Now, again, I could just keep shooting and take these here through 50. This simulation is simulating that, and it's assuming that the person here, Mr. Gomez, is truly an 80% free throw shooter. Now, I do unfortunately have to do a bunch of these, so it's going to be so great to watch me do all these. This is also, while you're watching, a good representation of our large counts. We're seeing, or not large counts, our law of large numbers. We're seeing that this percentage right now, not very good. But as we take more and more samples and we're getting closer to that true value, this one is sticking around 67, 68%, which is ironic. Anyways, we get, thank goodness, 68%, which kind of wild. But if we did this again, maybe we're not going to get there. So I'm going to quickly add a bunch. Let's add 200 simulations. And here's what we're going to see. Over a bunch of simulations, we have the majority of them kind of hanging around this 66% to, it looks like, about 92. We see a couple down here, 0.6, 0.58. But that's just to get an idea of what we did here. So your p-hats here, when I did this earlier, I got one that was 0.78 and one that was 0.84. These are just our samples. What you will notice is that this is the one I did on my own individually. So I did that a bunch of times, didn't just do 1,000 quick samples. This is our sampling distribution of p hat. So a big idea just to remember is that we know this is the sampling distribution of p hat. If we meet some conditions, we could do some other fun math with this, but that's not for this lesson. Instead, what does each dot represent? So what does this 0.96, what does that guy represent? And what it represents is one random sample of 50 free throws. So one random sample of 50 free throws. And the proportion of makes calculated from that sample or for that sample. Doesn't matter what word you use there, it's going to get the same idea across. Now, we can look at a couple things here. In 6, we're going to have to move back up to that dot plot. For an 80% free throw shooter, what's the probability that a sample of 50 shots ends with 64% or less free throws made based on this dot plot? Now remember, we're doing the 64 or less because that's what Mr. Gomez got. Now, this actually is Mr. Gomez's result. What we'll see here in class, we do this. I'm going to tell you right now, there are 50 dots. I took 50 samples here to make the math easier for us. But we only have 1 out of 50. Let's use not red, which gives us a 0.02 probability. Now, using number 7, based on our answer from question 6, does Mr. Gomez's observed result, so that sample that I observed him do of 0.64, give convincing evidence for my claim that he's not really an 80% free throw shooter? Hopefully what you're seeing, 0.02 is a very low probability. It's 2%. My hope is that you're saying yes. You're nodding your head, yes, this is. It would be unlikely. For Mr. Gomez, again, abbreviating to G, to get a p hat of 0.64 if he really was an 80% shooter. Now, that's what you're never seen this before, never talked about statistical tests or significance tests or anything in stats. That's what your brain hopefully comes to the conclusion of. It's unlikely. Doesn't mean it can't happen, just mean it's unlikely if he really were an 80% free throw shooter. So now let's fill in the blanks because it probably feels like there's some things we haven't talked about yet. And there are. Starting up here. These claims, we're not going to call them claims. We're going to call them hypotheses. The first claim is our null hypothesis. And how we write that is H lower O. And we're claiming that the true proportion is 0.80, 80%. This null hypothesis is the claim that what we claim should be happening. The second claim is our alternative hypothesis. We abbreviate in this specific scenario HA. E is less than 0.80. This is the other claim, right? Our alternative hypothesis is the other claim. Now, when we do these tests, I put this idea of assume number 1 to be in bold Because we always assume that HO is true. We always assume our null hypothesis is true. And then we perform our significance test to give us a something we can conclude about our null hypothesis. The next thing we're going to go down and do is look at number 6. This right here, what you just calculated, and this unit gets a little tough because this is called a p-value. It's our probability that we have. But we're going to have a lot of p's. We're going to have p being our true proportion, our p hat being our sample proportion. We can have an uppercase p, which stands for our probability. And then we have this lowercase p that I will always use as p value. And this here comes from what our proportion was of less than 64 of 0.64. We do have a way to interpret this. The way to interpret this is assuming our null hypothesis is true. In this case, that P is 0.8. There is a 0.02 probability of getting a P hat of 0.64 or lower purely by chance. What you'll notice is hopefully your thoughts for number 7 align to how this interpretation plays out. If you look, it's highly unlikely for Mr. Gomez to get a p hat equal 0.64 if he really was an 80% free throw shooter. We just formalized that. So actually, your answer to number 7 probably looks more like the interpretation of a p value, which then means, well, how do I answer number 7 then? It's a great question. Because 0.02 is less than 0.05, I'm going to stop right there. That feels like I pulled it out of thin air. We're going to figure out, some of you might already know, we're going to figure out why I used 0.05 later. Today, just trust. We reject the null hypothesis, and we do have convincing evidence that Mr. Gomez is a less than 80% free throw shooter. The 0.02, this p-value, is what allows us to make decisions on two things: whether we reject or fail to reject the null hypothesis, and if we do or do not have convincing evidence of the alternative hypothesis. Now, we're going to formalize all of this into those quick notes. And there's a lot. I'm going to start here. I know you can see all of them. I'll just leave them all there. Hopefully, you're also looking at the key I post. Our first target, we wanted to talk about hypotheses. So, P is the true proportion in context. We've talked about that a lot already with our parameter. When we talk about hypotheses, we have two. And it's not like when I first walked into a stats class, I thought, oh, like in my science class where it's if then. These aren't those kind of hypotheses here. We have two: a null hypothesis, which you'll see HO is P equals null value. And that looks kind of scary just there. What do you mean? It's what we think is happening, what we are expecting, what is claimed. Mr. Gomez claimed he's an 80% free throw shooter. So our null hypothesis was that the true proportion of free throws made is 0.8. Our alternative hypothesis, and I'm going to zoom into this, that looks scary. You will not have three alternative hypotheses. You have one. What this is saying is that you can either have a null hypothesis or an alternative hypothesis where our true proportion is less than the value we think it is, or greater than. You'll notice we used the less than here because I thought he was a less than 80 shooter. If you are strictly less than or strictly greater than, this is what we call a one-sided test. We're just looking at one side. We didn't care in this lesson that if Mr. Gomez was better than 80. That wasn't my claim. My claim was less than. We also have what we call two-sided. This is where our alternative hypothesis, we believe that whatever our null value is, it's just not true. We have, when we do these things, it'll be apparent. For a little bit, we're going to focus on these, but it doesn't mean this won't play a part here. So just so you're aware. Now, looking at full conclusions, what you just did is a significance test. Now, you did a simulation. AP exam, you're not going to have to do a simulation. No one's asking you to pull a bucket of beads out and do a simulation or a spinner and do a simulation. We will have things to do for significance tests to calculate. Right now, though, what's important? Interpreting a p-value and our conclusion. Starting with interpreting that p-value. Assuming that our null is true, and you do have to list what that is. There is a p-value, that's the calculated value. Probability of getting a p-hat of whatever happened, or more extreme purely by chance. I want to talk about more extreme. That doesn't mean greater than. More extreme means further away from our distribution. You'll see in this example of our lesson, more extreme would actually be everything less than 0.64. So more extreme doesn't just mean boom. It's you have to use your context of what you're talking about. Okay, let's talk about the conclusion because this can look scary too. This is one of those things, just like we're 95% confident. This is the thing you have to memorize and do word for word, or as I like to say, bar for bar. And you have two options. What you'll notice, the purple is above the underlined red sections because you're filling in the blank. It's kind of like Mad Libs. Because our p-value is less than, this is alpha. We'll talk more about alpha as we get into things. But because our p-value is less than alpha, we reject the null hypothesis, and we do have convincing evidence for the alternative hypothesis. You have to fill in the context. You can't just say evidence for null or for alternative hypothesis. You have to fill in with the context. What you'll notice in purple, if our p-value is greater than this alpha value that we choose, we fail to reject the null. And we do not have convincing evidence. Don't let this trip you up, though. We only have two options. We can either reject our null hypothesis or we can fail to reject. There is no such thing. So we do not accept a single thing in AP stats. That is bad. Because we could do more simulations, more trials, and maybe this changes. We don't know for sure. We never accept. We can say we failed to reject, though. Failing to reject the null does not mean the null is true. It just means we cannot reject it. In other words, we don't have convincing evidence of our alternative. That's all that's saying. All right. Make sure you do your check your understanding. These are really important. We'll talk more about alpha levels in a little bit. I know some of you are probably scared of that. What's that talking about? It will tell you in the problem, but we'll get there. All right, guys. Make sure you follow 9.2 after this.